Hey everyone, today we're going to be doing 8th grade number 25 from SBMT 2018. The problem is an equiangular, all of the angles are equal, hexagon ABCDEF has sides AB equals 6, BC equals 8, CD equals 10, and D equals 12. We wish to find the length of FA. So here we have an equiangular hexagon. Obviously it's not drawn to scale, but we just want to clarify that this is an equiangular hexagon where all of the angles are 120 degrees. So let's start by labeling our points. We're going to call this point A, let's call this point B, and then we're going to go around in a circle and label all of the points. C, D, D, E, and F. I apologize if they're a bit hard to read. So let's label the lengths we know. AB equals 6, BC equals 8, CD equals 10, and DE equals 12. Now, this is the length we want, right? How could we go about finding it? Well, this problem has a key insight. First, let's start by considering this angle. It's 120 degrees, and this angle over here is also 120 degrees. Now, let's consider what happens if we extend FA to meet the extension of BC. So we're going to extend it in a straight line, and they meet at a point right over there. Now, let's do the same for all of the other three sides. If we extend FA this way to meet DE, and if we extend BC this way to meet the extension of DE. So now, we have three little triangles on the edge. And look, we've also formed one big triangle. But what's special about these triangles is what we have to notice. Well, because this angle is 120 and lines form 180 degrees, that means this angle must be 60 degrees. And the same goes for this angle. This has to also be 60. And because the angles in a triangle sum to 180 degrees, and these angles are both 60, that means this angle also has to be 60 degrees. And that means that this triangle is an equilateral triangle. We can do the same reasoning to find that this triangle over here and this triangle over here, they're both equilateral triangles. And another thing is, this whole big triangle we just formed, it's also an equilateral triangle because this angle is 60, this angle is 60, and this angle is 60. So we formed four equilateral triangles by extending the lines. So let's label the extra information that we now know. Because AB is 6 and this is an equilateral triangle, this will also be 6, and this length is also 6. By this length, I just mean up to here, and like here to here. And the same holds true for over here. This length over here is going to be 10, and this length over here is going to be 10. So now let's consider what we know. The side length of the big equilateral triangle has to be 6 plus 8 plus 10, and that's just 24. And we want to use that somehow to find FA. Well, if this side length is 24, and these two portions of this big side length sum to 22, because 10 plus 12 is 22, that means this must be 2 to make this all 24 in an equilateral triangle. And if this is 2, because this little triangle is also equilateral, this has to also be 2. And now we consider our big equilateral triangle again. We have a 2 here and a 6 here. 2 plus 6 is 8. Because the whole side length has to be 24, FA is just going to be 24 minus 8. And that is 16, which is indeed our final answer. The key takeaway from this problem, that's an insight which isn't easy to see, is that we can extend these lines to form small equilateral triangles in addition to a big equilateral triangle. And that's a very common strategy when solving problems involving equiangular hexagons and not regular hexagons. Thank you for listening.